Hello students, welcome to Senior College Mathematics. Topic of discussion is matrices and determinants. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for JAM, for NAPTEP, or any other external exams into high school all over the world, this lesson is for you. You are in the right place. Petakus Education Community. Lesson 8, Solution to matrix equations using determinants. Solution to matrix equations using determinant. What this means is that you can solve equations in matrix using the concept or the steps of determinant as explained in lesson 7. Before that, for updates, follow Petakus Educom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like this video, share it to your friends, your colleagues, your classmates. You can also follow us on Facebook via fb.me/PetakusEducom, Instagram at PetakusEC, Telegram t.me/PetakusEducom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus Education Community, where you have access to quality, unlimited, and simplified mathematics teachings in series. Okay, so we have more examples. That is example 23. Find the value of t for which the determinant. Find the value of t for which the determinant of the matrix. This matrix is 0. Now, because the entries are enclosed in a round bracket, it is called a matrix. If you remove the round bracket and introduce the symbol of matrix, also known as a symbol of absolute value, what you are doing now is determinant. So you can see now determinant of the matrix because of this symbol and is equal to 0. Hence, find t. So you have matrix equations using determinant. Like I said in lesson 7, you can expand along any row, but I prefer expanding along the first row. But because it's a 3 by 3 matrix, you have the checkerboard sign, where the first entry there is plus, second one negative, third one negative. And also told us that if you expand along a row with 0 entries, it shortens your solution or the steps involved. So if we expand along the first row, since it has 2 0, it means the last 2 terms will be 0 automatically. That is the meaning. Okay, from the step that we explained in lesson 7, since I'm using first row, I will take the first element in first row, that is t minus 4. So I will have t minus 4. Then I will delete the entry in the first row and second column and first column. Entry in first row, first column. First row, first column. So you have a 2 by 2 matrix that is left. That is what you have here. Before, when you have 3 by 3, the idea is to reduce it to a 2 by 2 before you can evaluate the determinant properly. Okay, now that is for the first entry. We move to the second entry in the first row, that is 0. Okay, that is 0. The checkerboard sign assigned to it is negative. Then you delete the entry in the first row, second column. So you have two columns or two rows left, but we take it column wise is more better here, where the first column is -1 plus 3, what you have here, and second column is 1 then t minus 2, what you have here. That is for the second entry. That is for the second entry. For the third entry, that is also 0. The checkerboard sign to it, okay, is positive, not negative. Checkerboard sign to it is positive. So what it means is that delete the entries in first row and third column. You are left with a 2 by 2 matrix. So these are the entries as you have in this place, and you equate it to 0. After doing that, we apply the steps for obtaining determinant of 2 by 2 matrix, and that is difference of the product of the two diagonals. So for the first place, you have the first entry outside. You take this product is t plus 1 times t minus 2. This is the product. The difference there is minus, then 1 times 4, you have 4. 0 times everything here, 0. 0 times everything here, 0. Then we equate it to 0. We need to expand this term, that is this. If you expand, you know the rule. T times the second bracket gives t squared minus 2t, and 1 times the second bracket gives t minus 2, then minus 4, the last term there. So when you add the like terms, you have t minus 4 multiply t squared minus 2 plus minus 2t plus t is minus t, then minus 2 minus 4 is minus 6. If you choose to expand this t further, you are going to have a complex equation. And when you have this type of thing, what you do is that you equate each of the term to 0. But here we need to factorize the quadratic term. That is this term, factorize it further before we equate each term to 0. Now we have a simple case here. You look at 6, 2 factors of 6, that the sum is 1, that is coefficient of the middle term. The sum is minus 1 and the product is minus 6, that is minus 3 plus 2. The factor of 6 minus 3 plus 2 will give us minus 1 when added and minus 6 when multiplied. And you know the two factors are used to replace the middle term in terms of t. So you have minus 3t plus 2t. Once we achieve this, the purpose is to have 4 terms that are grouped together. So the first group is the first 2 terms, t squared minus 3t, then plus. The second group is the last 2 terms, that is 2t minus 6. Okay, so this term is also outside. From the first group, t is the common factor there. You factor out t. So if you use t to divide t squared minus 3t, you have t minus 3. From the second group, 2 is common. If you factor out 2 and use 2 to divide the second group, that is 2t minus 6, you have t minus 3 is left, then equal to 0. You observe that t minus 3 again is common. When you factor out t minus 3 from the first and second group, you have t plus 2 remaining that will form another bracket. Now we have 3 factors. So you equate the 3 factors to 0. T minus 4 equal to 0. T minus 3 equal to 0. T plus 2 equal to 0. So you have a linear equation. To get t, you simply transfer the constant term minus 4 minus 3 plus 2 to the right hand side. That gives t equal to 4, 3 or minus 2. You have solved the equation in matrix using determinants. Okay? Example 24. Find the non-zero positive value of s which satisfy the equation. This symbol there is clearly determinants. We want to solve this matrix equation using the symbol of determinants. All right. One thing we must do here is to expand. And we want to expand along the first row. The checkerboard sign there, the first entry will take positive, second entry negative, and the third entry is positive. So you take s, the first element or entry in the first row. But you want to expand along the first row. That is the s that you have here. Okay. After that, you have to cover the element in first row and first column, so that you are left with a 2 by 2 matrix with 2 rows, S1, 1s, as you have in this form. So you have in that form. Okay. Next is the second element in the first row of expansion. That is 1. So after taking 1, the checkerboard sign to it is negative, so you have minus 1. Then you delete or cover the entry in first row and third column and second column. You are left with 2 rows, 1, 1, 0, s, or 2 columns, 1, 0, 1, s. So you record them down in this form. Are you following? Lastly, you take the third entry in the first row. The checkered board sign to it is plus, so you have plus 0. The meaning is that you cover the entry in the first row and third column. You are left with a 2 by 2 matrix with the 2 rows, 1s, 0, 1, or 2 columns, 1, 0, s1. So which you record in this form. The next step is to find determinants of matrix of order 2 by taking the difference of the product of the 2 diagonals, where you start from the leading or main diagonal. So you have s outside, you multiply s by s, you have s squared. This minus now is the difference of 2 diagonals. then you take 1 times 1, that is 1. The second entry you have minus 1. 1 times s is s, minus 1 times 0 is 0. The coefficient of the third entry is 0. That makes it 0 equal to 0. Okay, so we have s into s squared minus 1. Then from here, s minus 0 is s. If you multiply by 1, you have minus s. So we have first term and second term. Here, I didn't bother to expand because I'm saying it that when you expand s squared minus 1 by s, you have s cubed. So you are having a higher degree. And of course, to solve that, it will be stressful. So once I'm seeing s squared and there's a term outside, so I will leave it to see if I can factor out a common term later. You get that? Okay. So from the first term now, s into s squared minus 1, and the second term s, you can factor out s. So you factor out this s. From the first term, you have s squared minus 1 remaining. So you know the s you factor out is divided through now. So if you divide this s by the s outside, you have 1 remaining. So if you open the bracket, you have s squared minus 1 minus s times s outside now equal to 0. So you have s squared minus 1 minus 1 is minus 2. So it's very easy for us to solve this way. So you equate s to 0, or s squared minus 2 equal to 0. When you transfer the constant minus 2, you have s equal to 0, or s squared equal to 2. You know, when the power is 2, that is quadratic, you are expected to have 2 results. So if we take the root of 2, we are going to assign plus minus to it to give us 2 results. So s equal to 0, or root 2, or minus root 2. That is the meaning. When you are asked to find the non-zero positive value, that means we have to discard this answer s. This answer s equal to 0 because it's 0 now. We want non-zero. When we come here, we have 2 non-zeros digits, or yes, that is plus root 2 minus root 2. Because we don't need minus root 2, we discard it and take the positive value of s, that is root 2. Out of the 3 answers, because of the given condition, non-zero positive value of s, so we have root 2 as the answer that satisfies the condition and the equation generally. Okay? Example 25. If determinant of Q of this matrix is equal to 2, then find matrix Q. So you already have the matrix equation in determinant form. Then you are asked to find the matrix. That means you have to get S first before you can find matrix Q. So simply you have determinant of the matrix equal to 2. If you expand along, so here we are not expanding along first row or second because it's already 2 by 2. So you go straight by looking for the difference of the product of the 2 diagonals, where you start from the main diagonal, that is s plus 4 times s minus 1. That is the main diagonal, minus is the difference. Then you have s times s plus 1. That is what you have here, equal to 2. So here we can expand, yes, because you can't factor out anything. So you expand. So when you expand this term, s times minus 1, that is s squared minus s. Then you have 4 times s times minus 1. That is 4s minus 4. Minus s times s plus 1. That is minus s squared minus s equal to 0. If you check very well, s squared minus s squared is 0. Now minus s plus 4s is 3s, minus this s you have 2s. The constant there is just minus 4. You bring it equal to 2. If you transfer the constant term minus 4 to the right hand side, you have to get 2s before you get s now. So you have 2s equal to 2 plus 4. 2 plus 4. 2s is equal to 6. To get s, divide both sides by 2. So s is 6 divided by 2, and that is 3. So we know the value of s. We are asked to find matrix Q. Look at matrix Q now. So what I use here is round bracket, not the symbol of determinant. Hello, I want to get the matrix Q. So I will use a round bracket or square bracket. See that? So I'm just bringing in this matrix but putting it in a round bracket where I will replace s by 3, its value. So you have 3 plus 4 here. You have 3, then 3 plus 1, then 3 minus 1. And that is 7, 3, 4, 2. So you have obtained the matrix from its determinant. If you check very well now, determinant of this matrix now is 2. That is the 2 you have here. Let's check that. The first that is 7 times 2 is 14, minus 3 times 4, that is 12. And 14 minus 12 is 2. That confirms your answer, that it is correct. Okay? Example 26. Given that matrix Q is equal to this, now Q plus P equal to this, evaluate determinant of Q plus 2P. This question is direct. You have matrix Q, you have matrix Q plus P. You are asked to evaluate matrix Q plus 2P, but you don't know P. So from Q plus P and Q, you have to get matrix P. So this is, you start from the one that contains matrix P, that is Q plus P equal to the matrix. For you to get P now, you have to transfer plus Q to the right hand side. So P is equal to the matrix minus Q. And what is matrix Q? This is matrix Q, which you put there to replace Q. So what you have now is subtraction of matrices. Since you have 2 by 2 matrices, the same order, it means that subtraction is defined, where you subtract corresponding entry to corresponding entry. 7 minus 6 is 1, minus 2 minus 0 is minus 2. For the second row, 6 minus 4 is 2, and 8 minus 5 is 3. Now that you know P, then let's look for 2P now. 2P is scalar multiplication, where 2 is used to multiply all the entries of matrix P. So 2 times 1, you have 2. 2 times minus 2, minus 4. 2 times 2, that is the second row now, you have 4. And 2 times 3 is 6. So we look for Q plus 2P. Are you seeing the progression there? Q plus 2P. So this is matrix Q, This is matrix 2p. We are taking their addition. When you add corresponding entry to corresponding entry, you have 6 plus 2, that is 8. 0 plus minus 4, 0 plus minus 4, you have minus 4. To the second row, you have 4 plus 4, that is 8. Then 5 plus 6, you have 11. Then determinant, you introduce determinant symbol. Then you take the entries of the matrix Q plus 2p and put them under the symbol of determinant. Then you take the difference of the product of the two diagonals, where you start with the main diagonal 8 times 11. What you have here, the difference is minus first before minus 4 times 8. Minus 4 times 8 as you have it here. So 8 times 11 is 88. Minus times minus is plus. 8 times 4, 32. And when you add, you have 120 as the result of evaluating the determinant of Q plus 2p. Hello, are you still there? All right. End of lesson 8. Thanks for watching and learning with Petakus Education Community. Don't forget, watch out for more from the voice of Petakus. From the voice of Petakus. For questions and inquiry, use the comment section. For the complete package of this topic, lesson 1 to 11, for offline usage, that is using without data, what I mean, contact the voice of Petakus via this WhatsApp number or through the email address. At a very little token, you get the complete package delivered to you. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you big congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be led. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely, and the Lord will bless you. The voice of Petakus says goodbye for now.